Hi, my name is Adela. I'm an interior design student from Poland, and I would like to show you my project. I see interior architecture as a broad and limitless subject. For me, it concerns the creation of all space in general. It's a field welcoming of experimentation and reflection. The line between art and engineering exists only in our minds. The words of Theo Jansen, whose works have been an inspiration for this project, capture the design's main idea. I wanted to create an experimental space that would redefine the notion of architecture, enhance it with other qualities, meanings, creating a new experience. The characteristic of architecture that stood out to me the most was its stillness, its grand presence. I wondered what would happen if into all that stillness one introduced its opposite, change, dynamicity, and movement. The Quaver is located on Orłowski Pier in Gdynia, Poland. The idea was to create movement in the design by introducing mechanical structures as its construction base. The motion-giving factor would be the construction's interaction with the environment, in this case, the sea waves. They move the design, its individual wooden modules. This approach unites the architecture with its surroundings and creates a feeling of a living machine. The name Quaver comes from the unstable nature of the structure. The design consists of three main parts, of which the pier is the core. The three parts include the main deck area, where the main utility sector is placed, the body of the design, the mechanical wooden modules, and the design's engine, the WPRC floating deck, which allows sea waves to move the structure. The height of the wooden modules allows one to walk safely underneath them, even in the case of waves of non-average amplitude. Sea waves cause the movement of individual modules of the Quaver. Analysis of the characteristics of sea waves at the location, Orłowski Pier, and research conducted on patterns of sea wave movement led to the final design of a single mechanical module. Its symmetrical construction allows for independent movement of the left and right columns, allowing different waves to determine the structure's movement at the same time, making the movement more organic and unpredictable in character. The WPRC floating units assure a beam's buoyancy and allow each side of the module to follow the individual up or down movement of a sea wave on either side of the pier. The main parts of the machine, which encapsulate the pier, were created with individual mechanical moving units, where construction can be divided further into three main components. The first are the wooden beams, which articulate the movement transferred onto the mechanical units by sea waves. They create the quavering tunnel surrounding the main deck of Orłowski Pier. They can move individually due to the use of self-lubricating wooden bearing systems, connecting the horizontal beam with the vertical beams. The second component are the WPRC floating, air-filled modules attached to the bottom of each vertical beam, keeping it afloat and making it possible for sea waves to move the mechanical unit. The third component serves a crucial stabilizing function of the former two components. It is a wooden crate attached to the base of Orłowski Pier, guiding the vertical movement of the wooden beams, inhibiting any horizontal motion. One of the goals of the design was to create an experience of walking through or exploring a living structure, experiencing architecture in its dynamicity. The machine was therefore divided into two main utility sectors, placed on the main deck and on the sea level. In Utility Sector B, one can see the machine from the perspective of its engine by walking on the floating deck of WPRC units at sea level. It requires one to interact with the sea as well as the structure. Utility Sector A, the main deck area, allows one to see the core of the structure from within. The environment acts upon each beam, creating a cascading effect in the tunnel. The path through the core leads to the open view of the sea. Along the way, one can rest on special benches replaced with raw wooden logs, or interactive natural sculptures. Low carbon footprint of the project was an additional objective. It was measured by the carbon footprint of its materials. Therefore, the main materials used were locally harvested spruce logs, subject only to barking, wood used in self-lubricating wooden bearings, minimal amount of construction steel, and finally, WPRC, or wood plastic recycled composite. The use of WPRC instead of plastic lowered the potential carbon footprint of the design thrice, as calculated in the Begariat's material pyramid. All materials used are subject to recycling. And finally, the best way to conclude my presentation of this project is to quote Theo Jansen once again. The line between art and engineering exists only in our minds. Thank you.